I welcome all the participants back for the last session of the FDP, the 13th session, to be continued by uh, the speaker of the previous session, Mr. Sanjay. And over to you, sir.
Thank you. So before starting the demo, let me share you one zip file. Just check you are able to access it. Yes. Can you check the chat window and confirm?
Sanjay, have you posted this for the participants here?
Yes, yes.
Okay,
If participants wish, they can download it and try it with me, or you can see just the demo what I
great. So, dear participants, there is a small announcement here like there is material being posted in the chat window by the speaker. You can either download it and you can parallelly work with sir, or probably you can just get to what sir discusses and later you can make use of the downloaded file. I hope I'm clear about the announcement. Can anybody respond me back in the chat window, please? I do repeat, the speaker has posted a material in the chat window and you have two options. Either you can simultaneously download, probably if you're working and listening through a laptop and you can work parallelly to him, or you can just listen to him and make a note of it. And finally, after some time later, when you have some free time, you can work with the file. Great. I have the
Great.
responses. And Sanjay, it seems that many people are ready to go on with.
Sure. Yeah. Are we giving some time to them to download, or just we can
Okay.
start?
Now, the participants can enter +1 in the chat window in case if you're downloading. So sir is asking live if you're downloading, he will give you some time and he'll start with the session. Probably for the downloading and getting ready.
Great. Yeah.
If you have decided to go with the option 1 of working parallelly with the sir in laptops, probably give enter +1 in the chat window. If so, some time can be given for you to parallelly work on with. Great. There is one person who has responded. Okay.
So you can open Google Colab. I have posted that link as well.
Dear participants, sir has given you certain time. See to that you can parallelly work with him in the laptop and see to that you download the file and have a copy with you. And we are giving you a pass here for making all these process get ready.
Yeah, we can start by 4:45.
Sir has two material getting posted in the chat window. One was a material in a zipped file format and the other was the link to the collab.
We'll give 1 more minute, ma'am, and then we'll start.
I hope I'm audible to everyone.
Ye-
If you're ready with the downloaded copy, kindly put it in the chat window so that sir will start with the explanation. Dear participants who have downloaded the material and moved on to the collab can respond back in the chat window stating that either yes or ready so that sir will start explaining it. Yes, people are, people can hear us back and they are also ready to do it parallelly.
Yes.
Sanjay sir, I
Uh,
think you can get proceeded by now.
yes, ma'am. Am I audible, and whether my screen is visible, ma'am?
Yes, you're audible and the screen is visible. And there is a small announcement to the zip folder is available there. One second, Sanjay. Somebody is
Yes.
asking me. Is there available in the chat window? Kindly check it out. And the link to the collab is also there. Great. They have found it, it seems. Sanjay sir, you please get continued. In case if there are any kind of messages there in the chat window, I'll get back to you.
Yeah, sure, ma'am. So just we will go with the basic introduction of Collab, so that someone new to Collab will get used to it. So this is a free platform. So why I have chosen Collab is It was provided by Google for us to as free to code, and then we can access the GPUs and TPUs as well for a certain period of time. So you can change. I think see this side. So you can change your GPU and CPU to GPU and TPU. So it is very great to work. And then see, no initial setup is required for Google Colab. See, now if you are working in Visual Studio or any such big applications, you have to install all the prerequisites before itself. But here, see, the TensorFlow will be already installed. Likewise, all the most of the packages will be pre-installed. See, you can run the first command and check. It will show as requirement already satisfied. See, the NumPy, everything will be pre-installed. So you can proceed with the first line of code, pip install TensorFlow and confirm if it is showing the same. Just I have given the actual code in two formats. That is, one is the IPYNB file, which can be directly get opened with the collab, or else if collab is not working directly, I have posted a notepad where it contains the actual code. You can open it and we can proceed step by step. Yes. So are you following? Let me check that.
I'm getting back with the participants also, Sanjay sir. Please don't worry about it.
Oh,
Participants, kindly respond back in the chat window so that sir will get continued. He's giving you a pass to ensure that whether you are able to get every step that he's explaining. So can anybody respond me back in the chat?
so before
If the
going that, I
participants are
have
responding yes, Sanjay, I hope you
okay.
can get continued.
Yeah. So before going forward, I have to tell one more good feature that you can code and as well as text. So there is an option to document also. So step by step, if you want, you can document this code as well. And you can, for simplicity, I'm clearing the output. So now we can upload the actual image. So for that, Collab has a function called files where we can upload it. And this IO command, IO function, right? That will be saving that image for this entire session. While you close the session only, the image memory will get vanished. So now let's just paste this upload command and then we will run. Just choose the hippo image from the zip file. See this function img is the image uploaded. Show function will display the image when printed and show when it is visualized. So now we successfully uploaded the image. If it is done, kindly the thumbs up so we can continue with the next step.
Sanjay, sorry for interrupting. There is a participant who feels that the font size is very small. So is it possible to zoom it out?
Yes.
Yeah. I hope now it will be probably in a high visibility for the participant. Yes, the participant has thanked you back. Kindly proceed.
Oh, no problem. So shall we move to next step? Whether all have uploaded the image?
Participants, please put your responses in the chat window so that I'll get back to Sanjay. If you have any difficulties till this step, you can put a message. If you are proceeding properly, you can put yes. Yes, participants have started telling yes.
Okay, good. So now so this demo is for only adversarial attacks. So I have loaded a predefined, that is a predefined model from which has been created by Google itself. That is MobileNet version 2. Okay. So this is a lightweight convolutional neural network pre-trained on ImageNet dataset. So that ImageNet dataset is also developed by Google only. So one second. Yeah. So first I will give a brief about this MobileNet version 2. So it is developed by Google and it is designed for efficiency and high performance with few computational resources. Like, see, we are able to run this MobileNet version 2 in the CPU portion itself. It doesn't require any TPU or GPU. Okay, so some of the key features are depth-wise separable convolutions and then linear bottleneck layers. So I told this MobileNet version 2 is pre-trained on ImageNet dataset. So this is one of the largest dataset, most commonly used dataset for image classification. So this dataset contains 14 million labeled images, and some of the labels are classes are animals, vehicles, objects, and scenes. So if you upload any animal, any object, it is able to recognize it. And then, okay, now, so you can do up to this step, that is uploading the model, a pre-trained model. So it will take 2 minutes to upload and download. Since this demo is for adversarial attacks, I am getting a pre-trained model. So if you wish to research in this area, you should build the model, that is, you should build it from scratch. See, the weights has been given as ImageNet, that is the ImageNet dataset is loaded to the MobileNet version 2 model. So now it is completely done. But for actual implementation, like deepfake, actually I researched on deepfake, so it took nearly 2 to 3 days to train the model itself in a GPU system. So yeah, but for your basic understanding, we are just loading the pre-trained model. Now, if loaded, we can go to the next step.
Participants, if you are ready with that, sir will get proceeded. Can somebody respond back in the chat window? People are trying there using your laptops. In case if you need time, we will give a pass for every step. Yes, it seems that they're proceeding with. I hope you can proceed.
Yes. Okay. Now, the image type should be converted to compatible with the mobile net version 2. So, what is the requisite is image should be size should be 224, 224, and the pixel values should be normalized, and then we should add a batch dimension. So, these are the prerequisites for an image to get compatible with the MobileNet version 2 that is developed by Google itself. So just we will run this to make sure the image is in compatible for the model. So just we know about resizing and normalizing. Batch dimension is nothing but the image input image is reshaped to include a batch size. Okay, so the batch size of the training model. So in this case, it will be like 1, comma 224, comma 224, comma 3. And finally, the image is converted into a TensorFlow tensor for compatibility with the model. So if this step is done, we can proceed to the next.
Participants, if you're proceeding with the same steps and getting the same results, probably you can respond back as yes in the chat window. And that will be informed back to Sanjay sir. And in case if you need a pass, you can also tell back. Is it fine to get proceeded? Kindly type yes in the chat window. Yes, they are asking you to get proceeded, sir.
Yes. Okay, ma'am. So now coming to the actual prediction of the image. So we already know it is a hippopotamus. So we will check if the model is predicting it correctly. Okay. See, the original prediction is hippopotamus with confidence 0.03. So just let me give a glimpse of this uh, code lines. So the prediction code, right? So the pre-processed image we got is fed to the model for inference. See, we are giving the image to the model as for prediction, and then we the decode underscore predictions. So this line maps the output probabilities to human readable class. Okay, so from machine readable to human readable classes. And then the final print statement prints the predicted class label and the confidence score. So how much confidence it is saying as it has a hippopotamus. Okay. If it is done, we can go to the actual attack.
Participants, you can post your answers in the chat. If it is yes, we can get proceeded. Yes, there is a participant who has responded back.
Okay, good. Okay, so just we will have a quick recap on FGSM attack. What I have told, for FGSM attack, we need the sign of the gradient of the loss, correct? So, uh, see, I have calculated it mathematically before the attackers even done that mathematically only. But systems are also getting updated, right? So the actual calculation we did is done by a single function that is called gradient tape, which will be giving you the actual gradient of the loss of each pixel value in the image. Okay. So see, I already told we need a image, we need the strength of the attack, and we need the gradient value. So this gradient will be calculated by the tf dot gradient tape function. So this gradient tape function is a module which is already in the TensorFlow package. So no need to install it separately. So after calculating the gradients, we will see for the sign of the gradient, and we will add it to the original input image epsilon times, correct? See the formula, image plus the strength, that is the epsilon times the sign of the data graph. Okay. So that is what the whole code says. It is very simple to understand. You can put it in the chat box if you are not able to get any line of code. So the loss will be calculated using loss categorical cross entropy. So that is used to calculate the loss. So now let us run this and check what it does. See, we have attacked the image now. If any doubt, you can ask. We can revisit the slides and we will go through the process of the SQSM again and we will come back as there are plenty of time remaining.
Participants, you can post it in the chat window so that it will be a positive feedback for the person who is presenting to get continued.
Yeah.
As of now, there are no very big queries from the chat window, sir. It seems that people are responding yes.
Yes, in the sense we can continue, ma'am, or we have to revisit the
Yeah,
slides.
people are asking you to get continued. Now, even Vijay
Yes.
Kumar sir has said yes.
Okay, great. So now just we will be giving the adversarial image to get predicted by the model. If it is getting fooled or not. Okay. So just see, we are giving the adversarial image to get predicted to the model. That is the first line. And then just we will print the class. Just the second line we know it is the classes are converted to the human readable format. And then the third line is about printing the class with confidence. Okay. So just we'll run it. Okay. So what it is giving? See, I'll zoom it. A hippopotamus is predicted as cup, just a cup, teacup. Okay. But the confidence is 0.07. Okay. We'll plot it and see more visually. But as of now, everyone is good to go. We can proceed. See, different participants can try different epsilon values.
Sorry for
So,
interrupting, Sanjay. There
mm,
is one
yes,
small query from a participant there. Can
yes.
you tell about the difference between a parameter and a hyperparameter?
Okay, it's a great question. So, what I would say is parameter are the configuration model which are internal to the actual A model. Hyperparameters are explicitly specified parameters to control the training process, I would say. So, the exact difference is it parameter is essential for making prediction, but hyperparameter is essential for optimizing the model. So so let us take this example itself, epsilon value. So we are making the intensity more correct. So that will come under this hyperparameter. So we are optimizing the model. But to make essential for making predictions, we need weight, bias, correct? So that will come under parameter. Ma'am, is this clear?
Yeah, I hope the participant would be clear. I think Soundarya ma'am, you got the answer for the question you asked. So I think you can get continued from where you were discussing, Sanjay sir.
Yes, ma'am. So participants who are all continuing, so can you confirm whether we can move further?
Participants kindly respond yes in the chat window if we can get proceeded. Yes, people started telling yes.
Okay. Now we will plot the image. Just we'll plot the original and the adversarial image to get a better clarity. Okay. So see the original image prediction was hippopotamus, but after integrating attack, the model confused and it has given it as cup. Correct? So we can the attacker will come to a conclusion that fast gradient sign method is effective. So if you are interested, you can make changes in the epsilon value in the FGSM attack and try it again. Everyone got the same output, I guess. Hippopotamus for original, and for the prediction, you have got the cup. If you are interested, you can increase or decrease the epsilon value and try.
Sorry for
If not,
interrupting, sir. People are
yeah,
responding back saying that they are able to do whatever you're tracking. I think you can get continued.
yes. So if we can try it for epsilon values, or we can move on to other attacks. Can I get some confirmation? We will try it for some other epsilon values. Okay. See, let us go to the attack again and see where the epsilon value lies. See, we have given 0.001, correct? Now we will increase the epsilon value to 0.1 and try what the image gives. Okay, now we will run this. See, again it has given some other thing, brain coral, some coral reefs, I guess. Okay, so we will plot it. Okay, see, the original is hippopotamus. The adversarial images, it is predicted is as coral reef. But if there is a reviewer, he will easily found it as a fake image, correct? So this epsilon value is not optimal for FGSM attack. Now we will decrease the epsilon value 0.001. Okay, we'll try it for this. Okay. See, again, it is giving some other prediction. Water jet with a confidence level 0.11. Just we will see. See. Now again, we will decrease it and see to one more value alone, and we will move on to other attacks. Okay. See, if we increase to 2 zeros ahead, again it is predicting it as hippopotamus. See, so this value is not optimal. You can either choose 0.01 or 0.001. That will be optimal. Okay, 0.1 will also fool the model, but it can be easily identified by the humans. But uh, and 0.0001 is making the model again easily found the original the image value. Okay, so see, again the model identified it correctly, so we'll bring the epsilon value to an optimal thing. 0.001 will be better. So everyone have tried increasing and decreasing the epsilon values, I hope. If yes, we can move to other attack.
Sorry for interrupting. Uh, Sanjay sir, can I
Yes.
read that query to you from a participant called Dr. Veena?
Yeah.
Yeah. So Dr. Meena has raised a question like what actually happens when epsilon is multiplied with gradient and added to the original image?
Okay, that's a good question, ma'am. So, see, the epsilon is the strength. I already told. Like, if x times the attack is sent to the original image, the model is not getting fooled, then we have to make sure it is 2x. So the strength will be the epsilon value. So you are saying that I think you are meaning about the pixel values. So we are after adding the noise, correct? So just in the noise, if you are adding the epsilon, that is multiplying with the epsilon strength value, we will be make sure that the model is getting fooled along with the reviewer's eyes also getting fooled. So we have to choose an optimal value of epsilon. Other way, that is to make sure the model is getting fooled along with the actual image replica, I would say.
I hope sir has answered for your question and she has responded. Okay, sir. There is one other question from other participant, Sanjay sir. Can I ask you?
Yes.
What could be epsilon value in general? Does it represents a range?
Okay. It can be so attacker will be testing it for various attacks. Like sometimes a higher epsilon value could recur for any attack. But minimally the minimum value could be, I would say it is 0.1. Sorry, the maximum value could be 0.1. Other than increasing to above 0.1 lead to distortion of the original image, and we can easily identify it as a attacked image. So to make sure we are also not recognizing it as an attacked image, and also to make sure the model is getting fooled, we have to make sure the uh, epsilon values are so less. If it is less, not a problem. If it is high, we have to make some more research work.
I hope sir has answered your question. And Dr. Meena has raised a question, like, sorry to ask again. It
Yes,
doesn't
no
bother us,
problem.
madam. Shall I proceed, Sanjay?
Yes.
Yeah, Meena was the earlier participant who asked you about the multiplication of epsilon value with the gradient. So I'm
Okay.
reading you the question. Can you explain briefly about that gradient tape function?
Okay, that is just let me go to the PPT again if all participants are okay. Uh, Ma'am, shall I go to the PPT to
Yeah, you can
in
switch. In case if it takes time, we will wait.
yeah. So, see, actual process is finding the sign of the gradient of the loss. See, tracking back, we are first finding the sign of the gradient. So you go to back, it will be gradient. You are going back, finally there is a loss. First we will be finding the loss, correct? So this gradient tape, what it will do is, it will record the operations for the automatic differentiation. So gradient is nothing but differentiation, right? So this gradient will be computing all the differentiation values, ma'am. So to make sure this differentiation happens to all the pixels in the image, there is another function called watch, tape dot watch. So this tells the gradient tape to keep track of the operations performed on the input image. So this is essential because we want to calculate the gradient of the model's output with respect to the input image. I think I hope I have answered, ma'am. If you want any clarity, you can.
Yes,
Uh,
Dr. Meena has responded yes.
Great. Yeah.
She has thanked you. Probably, I think we can get continued, Sanjay
Yeah.
sir. Participants, I think sir can get continued from where he stopped earlier. So if so, can you put a yes in the chat window? Yes, people are responding back yes, so please get continued.
So participants would have now checked for different epsilon values. So I think it was interesting, right? So we will move on to next attack. see, learning attacks is only to make sure the model, to make you understand the attacks and make sure you are creating some new defense to mitigate these attacks. You should make it more ethically by not using it in a wrong way. Okay. So coming to the next attack, this is noise evasion attack. I already told it is just adding a random noise to the image, right? So what we will do is we will uh, create a random noise and the shape should be exactly same as the input image. And then just we are adding to the input image, and then we are making sure the pixel values does not exceed 1 and then does not goes below 0. So one question you may ask, what if the pixel values are going above 1, or what if the pixel values are dropping to 0? So what we can do is just, if it is, for example, the pixel value went to 1.2 means you can bring it back to 1. That's it. Anyway, if the pixel values are exceeding 1, value should be 1. If it is going back to 0, below 0, bring it back to 0. That's it. Okay. So just we will be doing that, adding the noise to the image. Just next step is clipping the value, and then just we are predicting the label given to the model. If the model is getting this noise evasion attack continues until the model is getting fooled. In the case of white box attack, in case of black box, it has a extra work for attacker to make sure he is querying the model again and again. Okay, I believe this is so simple, so we will run it. Okay. We will visualize it last so that we can have some
Sorry for
discussion.
interrupting, Sanjay. There is one question
Yeah.
here. Can I or
Yes, ma'am. Yes.
yeah, Udaya sir has raised a question. Other than epsilon value, is there
Mm.
any other value that makes an impact on the original image by adversarial attack?
Yes. Great question, sir. There are multiple that I would say it as a hyperparameter. So you can in case of a model, if you are having a model, there will be learning rate, right? So learning rate is there, epochs is there. So these also plays a vital role in making the model get confused with the image. So and the see, in this noise evasion attack itself, there is something called maximum iteration. So what we can do is, see, you can increase this value to 500 and you can decrease this epsilon value, so that the minimum value of epsilon also could make some a huge impact on the image. But I would say epsilon is the master for making the image more attacked in an attacked way. But there are multiple hyperparameters that are making the image more impactful. Is this answered your query?
Yes, yes, sir, you have done. So probably can get continued. Udaya sir, I think Sanjay sir has answered your question. You please get continued, Sanjay.
Yes. So we will visualize it, this noise evasion attack later. Just okay, we'll make it short. Okay, fine. Okay. I hope the participants who are running also following me. So we will move on to the next attack, patch attack. So this is one of my favorite, but in the case of humans, that is specific to deepfake or any facial recognition, it works efficiently. The model gets fooled for patch attack in a very good way, I say, a very drastic way. But for animals, objects, this patch attack is not working. Uh, I am too researching on this why it is not working, but we will continue with the attack as far as now. So as I told, for the patch efficient patch attack, first we need a patch pattern. Correct. See the second part of the code. Okay, 1 second. Okay. I already told we have to create a zero filled numpy array. Then yeah, it's my that I uh, created a way that patch should be in the center of the image. But you can wish anywhere the patch can be. It can be in the side, it can be in the bottom or anywhere. But I wish to be in the center. So for that, I have calculated the center of the patch pattern. Okay. So after calculating the center, just we have to determine the patch size. Okay. So see, this patch size determines how efficiently the model is getting fooled. Okay. So as far as this value is getting increased, the model the patch size will decrease because it is in the division. So we will run that as well in the later part. 1 second. And then finally the pattern will be created in the center. Okay. So after creating the pattern, we have to add it with the original input, correct? So first part of the code, just I told to be the patch pattern to be compatible, you have to convert it to tensor, ensure that the type is in float 32, and then resize it to the original input image size, add it. See, here I have given it as intensity, but it is nothing but the epsilon. Okay. You can give any name, but anyway, it's fine. So after that, we are clipping it to the valid range, and then we are returning the patched image. Okay. Just you can run. Yes, it is running fine. So we proceed to the next attack. So with this, we are finishing the attack part. Can we move to the next attack? Can anyone confirm?
Participants, if you respond yes in the chat window, it will be encouraging for the person to get proceeded. Yes, they started responding yes, Sanjay sir, you can get continued.
Okay. So this is just a simple attack I told, correct? So just I am making sure the model is getting fooled. We are giving some various brightness and contrast adjustments. So see here, just I have increased the brightness adjustment from minus epsilon to plus epsilon. Just I have hard coded the contrast adjustment. Okay. See, for the minimum value as contrast can make a drastic difference in the image, so you have to be very careful in choosing the contrast values. Okay. So then after that, you are adjusting it the brightness to make sure the adversarial image get full, and then the same for the contrast. After that, adding to the image, what you are doing is clipping it to ensure they are in the valid, the pixel values are in the valid range, and then we are giving to the model for prediction. Okay. So, and this attack also continues in the loop until the model is getting fooled. Okay. So we will run that.
Participants, if you're tracking, kindly please put a yes in the chat window. Yes, Sanjay sir. People are responding, so please get continued.
Yes. Now, just we have integrated each and every attack to the image. Correct? We have integrated 3 attacks now, apart from FGSM attack. Now, what we will do is just we will predict the labels of the uh, image. Okay. Predict the class index for the original image. 1 second. Okay. See now, this is for prediction and for visualization part. So we have giving it to for 3 different attacks. So just you run this. it will take time because see for noise evasion attack we have given 100 iterations, right? So it will run for 100 times to make sure the model is getting full. But I would say many attacks, suppose if A attack is applicable to one data set, that attack may not be applicable to another data set. So just we are checking that different attacks are applicable to this animal data set or not. I'm also not sure what attack will be applicable. We will conclude it at the final. So if it is done, we can go with the final prediction. Yeah. So any error you got while running this, you can kindly put it in the chat so we could possibly discuss and solve it.
Participants, you can post your status in the chat window. In case if you require more time or if you are doing it in track, kindly put a yes in the chat window.
Shall we move further? So here each attack has been carrying a replica of the original image and it is attacked. Not the image is attacked with the 4 attacks that together. Okay.
Participants who are executing can post your status in the chat.
Shall we move further, ma'am?
1 second, Sanjay.
Yes.
Participants, please do respond yes in the chat window in case if we can get continued and you are on the track. And if you need time, kindly please do specify that too. We will wait or give a pass here.
So if you have any query on the above attacks. We will reiterate to the attacks in this slide, and I will make sure you understand it better.
The participants are responding as yes. I hope so. We can get proceed.
Sure. So the final stage is the prediction. Okay, so we will see what the original image is getting predicted by the model. If it, we will check if it is getting fooled or not. Okay, so just run the final prediction code. See, that is the noise attack is not working fine. See, hippopotamus with the confidence of 91%. The original image itself as a original image as a confidence of 33%. But see the noise attack, it has given the output as hippopotamus with the confidence of 91%. So it is not going to work either way. See, one more thing to verify is check the confidence score of the original prediction. And if you are attacking the original image, if you get confidence above or that is more or less two times the above the original image confidence, then we can conclude that this attack is not suitable for this type of data set. Make sense? So we will omit the noise attack. Coming to patch attack, I already told patch attacks are not suitable for things and animals. I am too researching on this, but I'm just continuing to research. So this is also failed. But see, poisoning attack, it has worked successfully and it has predicted it as a hog. Hog, I think hog is just a pig, okay, male pig that is used for meat purpose. So we have the original image hippopotamus, but poisoning attack made the model to predict it as a hog with a confidence of 14%. So interesting, right? So if you are done with this, we will proceed to the visualization part. This is nothing but just we are giving the class to get predicting the adversarial image and just printing the predicted class with confidence, which is human readable. Shall we proceed further?
Participants, can you put a S in the chat window? Probably so that I can get continued. There is giving a pass to get your response back to proceed forward. So, yeah, people are responding yes, Sanjay sir, you can get proceeded.
Yes, sure. So meanwhile, if you have any doubt, please post it in the chat so that we can answer it. So now coming to the final plotting stage. Anyhow, this noise attack and patch attack doesn't work properly. We will come. We will conclude. We will come to the conclusion of whether FGSM attack and this poisoning attacks are working fine. But there is one more stage to get the final conclusion. That is, if the image is fooling the reviewer also, so that we are plotting. So let's see if it is fooling. See the original image. See noise evasion attack. It is failing to fool the model. Patch attack also failed. See coming to poisoning attack, it predicted and it fooled the model, but it failed to fool us. Correct? See, there is some variations in the image, original image, and the predicted. That is the adversarial image. So we can try changing the contrast and brightness to make sure both model and the human eyes are pulled. So once again, we will try it as well. Just go to the actual attack, poisoning attack. We will decrease the value of poison brightness. We'll decrease this maximum iterations as well. And then we will decrease this. First, we will, as contrast makes a drastic difference, just we'll make sure it is working fine for brightness amount. Okay, just we will check if it is working, model is getting fooled by brightness alone, and then we will come back to Python. Wait, it is getting executed. Any queries until it is getting run?
Something, sir, there is a question here from
Yes.
Dr. Meena. Can I read?
Yes, ma'am. Yes, sure.
Even in poisoning attack, we are getting 14% confidence only. Is there any way to improve the confidence?
Yeah, actually, now see, ma'am, the original images conference itself is 33% only. So, the problem is with the model that is not getting well trained on hippopotamus image. So, we will try running with another image. There will be, I think, there is one more image, elephant. So, it will give confidence of nearly 80 or 85. So that time, if you are attacking, the confidence will get increased. So it depends on the model, how it gets trained with the original input. See, the original input itself giving 33%. So adversarial attacked image should give less than 33 only. Correct?
The participant has responded yes and stated a thank you to you.
Yes. Welcome. So let's see it got run. Yes, it is running. Now we'll go to the prediction. Poisoning attack. See, I have changed the brightness value. I have decreased the epsilon and then decreased the maximum iteration. And then I have given the contrast value as 0. But let's see how it comes with the, let's see, it has mispredicted it as wall clock. The hippopotamus, it is predicting it as wall clock with the confidence 0.08. Now we will predict it using plots. Huh, interesting. I think contrast value has made some magic to vanish the hippopotamus. So see, just we can conclude here itself, like we have to be very careful in making the changes with the contrast and brightness adjustments. And they see, brightness no problem, but contrast plays a vital role in making the drastic change to the image. So easily the reviewers will understand that it is an attacked image. So if you want, you can try it for different values with these three attacks. I will wait. Meanwhile, I can also try that.
Dear participants, if you are ready to try whatever sir has stated, sir said like he's ready to wait. Is it fine from your end? If you're going to try, kindly put a yes in the chat window.
Yes. If anyone got a perfect adversarial image for poisoning attack, uh, let me know the values you have given. So meanwhile, I will also try. We will try together to get an perfect adversarial image for poisoning attack. Okay. As we have some more time for this session, so we can try and make you understand what the whole adversarial concept is. Is it okay for you, or we can go with any other thing you say? Just like we can explain some concepts which are not understandable, or you got some less insights than you expected, we can proceed there, or else we can try it.
Participants, kindly put your responses in the chat window. Please be interactive. You can post your Sanjay sir, participants are thanking you for the practical demo. Now, is it fine with
Okay, yes,
the way
ma'am.
sir states us to go on with? Few
Sorry,
people are
ma'am.
trying. Probably sir will also do it at the other end.
Yes. So
Yes.
yes, we will see who is getting an optimal value for perfect adversarial image in poisoning attack. Is it
Uh,
okay?
Meanwhile, Sanjay sir, there is a query. Can I read?
Yes, ma'am.
Predicting incorrectly with high confidence value. May we conclude what it is as good adversarial mission technique?
Okay.
Predicting incorrectly with high confidence value. May we conclude with it as a good adversarial mission technique?
Yes. Yes, ma'am. So, but as an attacker's perspective, it is good. But as a researcher and AI developers, we should not allow the machine learning model to make this happen, this confidence score to get increased, right? So as as far as attacker is concerned, he may be doing things as such, but we as an responsible AI researchers should not allow this happen to make sure our model is robust against that.
The participant has said okay, and there is one other query, Sanjay sir. Can I read?
Yes, ma'am.
Is there any method to detect these adversarial attacks?
In the sense like uh, okay, you are asking, we are defending, but is there any way the image is getting attacked, right? To know, to mitigate.
No. The participant has responded yes, and I think you can get continued with the flow, Sanjay sir.
Yes, ma'am. Just sorry, we are continuing with the demo, or
Yeah. We are getting continued. Participants, is it fine getting continued? You can put a yes in the chat window so that sir will go on with this flow. Is it okay for you, Sanjay sir?
yes, ma'am.
Yes. And participants started responding yes.
Okay, fine. Yeah, great. So, have anyone tried and got an optimal value of this, yeah, brightness and contrast values, and pooled the model as well as our visual perception? Let me try. We will try up to 545 and we'll move further. Okay. Just we'll go to that attack. Can participants respond? Anyone got any optimal value?
Participants, kindly respond to sir. Um, there is a query here, Sanjay sir. Can I ask you?
Yes, ma'am.
It is from Dr. Saravanan. With the rise
Yeah.
of generative AI creating images, how can we ensure that our security systems are functioning effectively?
So, to answer your questions, sir, it is a collaborative effort of government and the AI researchers to create some innovative and dynamic defense mechanisms. See, like we should be in very much proactive, that we have to be thinking ahead of the attackers. And see, if attacker is creating an attack, there should be defense created a way before itself. So in such way, the attacks can be mitigated and solved. So I would say a great way what I personally when I research will do. So uh, you know about some tech companies, they will be way ahead of in research work, and they will be doing some research related to this. So you can go to, so for example, if there is a you may take it as a Google itself. So you can go to the Google website, their company's documentation, and there they will be giving some more documentation on how they are mitigating, how they are way ahead of uh, uh, making their AI system robust. So using that, you could combine your idea with their their methods to mitigate. You can we can be way better to solve the issues. So as while I research, I do this. I go to some, if I have a research problem, I research for which companies are now working on that, and definitely they will post their documentation or some works in there. I will see for how they research, how they are working towards that, how they are going to solve. And if I can get some insights on that, I will work on it. So you can do such way to mitigate. It is an
I hope
just an
sir has
advice.
answered your questions, Saravanan sir. And here's one other question, Sanjay sir. Can I?
Yes, yes.
We believe the gateway for all transactions, but in between some hackers are there. How to protect it?
Okay. So you are coming to bank financial side. So how I think that has a different attack than this what we are discussing. So I believe I am not in a way to answer this, as I am not aware, but I will research it and I will get back to you.
Thank you, Sanjay sir. Meanwhile, other participants who are executing can get back to the chat window and put your status. Like sir was
Yes,
asking you to execute and get back with certain values, right? So please post it in the chat. Meanwhile, Sanjay sir, Saravanan sir has thanked you for answering his queries.
yes, no problem. Yeah,
Participants who are executing these exercises in Colab in your laptops can share your answers or the results in the chat.
yes. So while I am also executing, let's see. See, by this way, we can know that how attackers are very keen in crafting the inputs, right? Crafting the attacks to make sure the input is making the model fooled, and as well as it is making visually no difference. So that I have given this exercise. Uh, what I did is just I have commented the contrast part alone and tried for brightness. So I believed it worked, but it is also making some difference. So we have to be very optimal for to for that deepfake attack. It nearly took 1 week to make the optimal values to be fooled. So I just tried again and again to make an optimal value. So here we are trying as a collaborative. So I believe we can get an optimal value for poison. So if not, we can conclude that just fast gradient sign method is a best method to fool this model. There are multiple models that and various attacks can fool that model. So I cannot show defense here as defense requires rigorous training to make the model robust. So if any, so I'll wait for 2 minutes to make to check any participant has given an optimal value, or else we can continue further.
Participants, kindly respond in the chat. If required, expert is ready to wait for a couple of minutes. If you want to wait for a couple of minutes, post as wait in the chat, or if you want to get continued, type a S on the chat. Please be interactive. Either put a wait message or yes message in the chat. Wait will enable us to give you a couple of minutes, and yes will make us to move on with the yes. We are getting yes, Sanjay sir. We can move
Okay,
on,
ma'am.
it seems. One person has asked to wait.
Okay,
We'll wait for
we'll wait.
Bhuvan for a couple of minutes. And there
Sure.
are other set of 6 people who said us to proceed. So I hope so we
Okay.
can wait for Bhuvan for a couple of minutes.
Yes, sure. Ma'am. Yeah.
Bhuvan, is it fine? Yes, I think now we can get proceeded.
Okay, ma'am. So one more research aspect I would like to tell you is, suppose uh, see I saw a recent research article on reflective pattern disruptive analysis. That is, see, the deepfake is happening in the eyeball portion where the uh, light is get reflected. Okay, so they are making faking the eyeball of the human. So we have to make sure our model is is in the position to uh, correctly identify the defect. And see, defect itself is difficult. Adversarial defect is a further difficult value, as refractive patterns in real images are influenced by interaction of light with surfaces, right? So if you are interested, you can research in this area for creating any differences. So now I believe we have come to the end of this demo. So if you wish, we can reiterate anywhere you have any doubt, or we will go back to any slide to make sure you understand the adversarial concept better. If at all, we will answer for queries, and then
Participants, please be interactive. Post your options in the chat.
if you are interested, we can try this for that elephant image as well. What is fine, you can post it in the chat. I have given you two images, right? We can try it for the elephant image and check what happens to that image. Any responses, ma'am?
Participants, please post a S in the chat in case if you're getting on the same track with sir.
Shall we try it for the elephant image, or shall we
Yes.
reiterate anything? Yeah.
There is a yes from the participant side.
Okay.
Could many
Then
more
we will.
participants respond quickly whenever we ask you so that we can keep in track?
Yes.
Yes, they started responding yes.
Sure. Then we will try it for elephant and we'll go for QA. Hope you are enjoying this demo session. It is so it is interesting, I believe. And I would like to say, to know about any attack, first you understand how it happens mathematically, as this involves a huge mathematical computations. So first trace it manually, how it happens for a single pixel to get a deeper understanding, and then we can move on visually so that you will be so much you will get some better clarity on that. So we have tried that for elephants. Yes. See, I already told only FGSM attack is performing well for this data set. So this image is also proving us right that patch attack, see, it has not fooled the image. It has given us African elephant only, and noise evasion attack also same. But coming to poisoning attack, it fooled the model as it is predicted it as Tusker, but it is not failed to fool the visual perception. But coming to FGSM attack, see, there is no visual change, and see, beautifully it has fooled the model. Okay, so if everyone tried with it, and there is something called as iterative fast gradient sign method, which is the new that is refined version of fast gradient sign method. See, fast gradient sign method itself is too effective. The iterative fast gradient sign method is effective than this. What it will does is it will make sure the model is getting fooled. Until then, it will iterate it. It will have loops to run until the model is getting fooled. Okay. So there is more modified version of this attacks itself. Like they have set boundaries. They have created. Many researchers are creating, refining the attacks and researching in a better way, and they are just publishing the papers. So if you are interested in adversarial attacks, you can look into that, or you can contact me. I will send the proper uh, research papers to look into. So I believe everyone tried with it, and we can conclude, right? FGSM attack is the best for this model, for this mobile net version 2 model. For deepfake, which I researched, that 4 models are also performed well only. So I would say attacks are specific to models. So yeah, any queries you can post it. You can answer.
I hope participants are also trying from your end. So you can put your responses in the chat. The sir has shown you for the elephant image. In case if you're trying parallelly, you can post your status there in the chat, whether you get the same. Sanjay sir, there is a query. Can I read it for
Yes.
you?
Yes, ma'am.
Can you give one example about the attack in healthcare sector and the defense mechanism for it?
Okay. So I believe I have explained it in the slide. Wait, I reiterate. So see, I tried that for uh, making robust thyroid diagnosis. So at that time, I tried 4 attacks. That is fast gradient sign method and iterative fast gradient sign method, and that is other 2 attacks. So, ma'am, if everyone is okay with it, I will share. I will stop sharing and I will share it again. I will take
Okay,
that.
great.
Yeah,
Is it fine from the participant side?
just 2 minutes. I'll take.
Yeah. Yes, they are responding as yes.
Okay. Okay, that my screen is visible.
Yeah, it's visible, but probably not inside the slideshow, Sanjay sir.
Okay. 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 So while I researched, I tried for thyroid diagnosis. So from basic to severe stage. Okay, basic is benign and severe is malignant. So at that time, uh, I tried for four attacks: fast gradient sign method, iterative fast gradient sign method, PGT attack, and Carlini and Wagner attack. And but what I felt was four attacks are also on same methodology. Like they will be calculating the gradients value, and it will be the methodology will be alone different. Like iterative will use maximum iterations to make sure the model is full. PGD will be using a boundary to set the gradient value, and then the Carlini and Wagner attack will be slightly based on optimization value of founding the uh, optimal gradient. Okay, so what I would say is these four attacks works fine for me, but you can research some more attacks that are attacking the thyroid AI model itself, or you can go with attacking the training phase of the model. So there are multiple attacks you can try with it, but here also FGSM and IGSM work fine for me. Yes, I could show you for FGSM attack. Yes, see, I got the accuracy as 0.06 and loss is so heavy. And one more thing to note, X-ray images are more prone to that is we should be very careful in crafting adversarial samples in X-rays, as uh, minimal epsilon values will also will make a huge impact on the X-rays. So if you are considering that as well, then it is good to go. Think that's all. If I believe I answered your doubt, and
I hope so, sir has answered your question, Uday sir. Yes, Sanjay sir. Sir has responded yes.
yes. So there is some more time. So if you wish, I could reiterate any concept that you are not uh, get clarity, or any questions you can ask. I will try my best to answer.
Participants, if you want sir to iterate it again back, he's ready to summarize. Or if you have any queries, you can put it in the chat. You want sir to iterate, or if there are queries, the session will be open for the queries.
Yes.
Please put your opinions on the chat. There is a query, Sanjay sir. How can one become a AI developer?
Okay, actually, see, it's one's interest, right? See, during my PG days, I was a passionate ML researcher, and after that, my track changed to cloud path. But I would say I am not stopped with that. So I'm still researching on ML and AI. That is my interest. But uh, as far as becoming an AI developer, uh, what I will say is, 1 second. Uh, yes. So first, what I can say is, see, first you become strong in all the mathematical aspects of artificial intelligence and machine learning, and then you can focus on the AI specific knowledge. Like uh, if you are specific to deep learning, you can go with the neural network part, and if you are specific to the machine learning part, you can go with that. And if I am not sure about how you are asking this question, like how to get placed, or uh, how to research, how to become an active researcher on AI. But I am still researching, even though I am a cloud engineer. If getting placed is way different, you make sure you are strong in all aspects and apply it through LinkedIn or other platforms.
It seems that he has raised the same question to explain to the students.
So can I take your question as how to how to become an AI faculty?
No, I hope so. What I infer from the question is he has asked the same question to explain to the students, it seems. Am I right, Uday sir?
Okay, fine. I got it. Yeah.
No, let me get back from him because it, I think it was how I infer the question.
Okay.
Yes, I think I was right.
Super, sir. Yeah. Thank you. So first, I would say make sure the students are very much skilled in the programming language like Python, and then focus on mathematical concepts, as most of the students lack there only. So as while I am studying, I concentrated on the math part well. So tell the students to make sure that you study a linear algebra, probability, and calculus. That is more than enough, I guess. And then come to the machine learning actual part. So if the students are interested in ML part, you can go towards there. Or else if you are interested in DL part, you can make part there. Or if the students are focused towards NLP, natural language processing, it's very good, as it is rising technology now. So then after the students are way uh, understandable in their knowledge, then you can come with a real-time application. So, for example, coming to a chatbot, they can build a basic chatbot. Then come see how companies are using chatbots, and they can refine like the way the companies do. And finally, they can host it in some cloud platforms. And after all the building setup, you can make sure the things are done ethically, as we focused on responsible AI. I think I have answered it.
Yeah, Sanjay, I've answered the query, and there are two other queries there. Meanwhile, Uday has thanked you.
Yes.
The next query is, would you suggest a ML and AI learning platform for faculties to work on with?
Okay. um so what I would suggest is, you can use there are multiple online platforms, I believe. So uh, I think you can use Google AI and TensorFlow platform. That would be more. That I think that is free for some few days, I guess, 1 month or that. You can use that, or you can use Microsoft Azure AI. That while now I'm working currently on that only. So they are providing an Azure ML platform that is used to build, train, and deploy the models. So they have many predefined uh, uh, modules, like API for vision, speech, and decision making things. But I believe it is not free of cost. You can try that as well. And yes,
The next query is, can I, Sanjay?
yes, ma'am, yes.
What are the mathematical paths to be focused for ML or AI?
Yes, I think I have answered it while answering Sir Udaya
Yes.
Suryan sir itself.
Okay, so I
Yeah,
then quickly go to the other query. Is it fine?
yes, ma'am.
Okay.
If you want, I could reiterate that linear algebra, that part only, ma'am.
Uh, I'll ask the participant. Sharda ma'am, do you want to reiterate it?
I think she has thanked. Yeah.
I think she has given you a
So
thanks and she said no need. Uh,
yes.
she has noted it already, it seems.
And
So
about
I'll go to the other
federated
query, Sanjay.
learning, yeah. Uh, yeah, one participant has asked about federated learning, ma'am.
Yeah.
So yeah. So, as far as I know, I will explain. So, federated learning is also a ML technique where the training process is distributed across many devices or machines. So, like rather than being a centralized server, it is like distributing across many machines. So, the idea is to train a model on a decentralized server instead of sending to the centralized location. So, uh, if you want, I could brief it further, or it is enough.
Thank you, Sanjay. Shall we go to the other question now?
Yes,
So Rekha ma'am wants to unmute her.
yes, ma'am.
I'll try unmuting her. Rekha ma'am, you're
Ma'am,
unmuted.
can you hear me, ma'am?
Yeah, I
Ah,
can hear you.
yes, ma'am.
Absolutely. Please proceed.
Uh, yes, sir. Sir, this question is regarding federated learning. You told
Yeah,
like this is decentralized learning approach, right?
yes.
So I asked this question in the previous session also, sir. Since uh, the data are running in local model, right? So we may have multiple local model to make it as a decentralized approach. So
Mm,
when we train the data with the noise, like Laplace transformation, like we have so much of option for that.
mm,
So we apply differential privacy. So in that we
mm,
can tune the noise to make it as a more private one, right? So when we run that local model individually, we got some decent accuracy, sir. So accuracy is about 80 or 90. But
okay.
when we run each local model separately and aggregate all the model's accuracy at the end in the global server, so we got some less accuracy. So we keep on trying in that, and still it's a big issue for us, sir. So can you give some idea related to this?
Okay. So can have you increased? Have you see the iteration part? How it is like? Sometimes the less iteration, the less accuracy will be. So uh, can you check with the iteration part, like for training, final training?
Sanjay, is it like the queries are answered?
Yes, I'm answer. I think I'm audible, right, ma'am?
Yeah.
So, ma'am, what I too faced a similar kind of issue while I did my first research. That time, uh, what I noticed was the iteration part. I missed out the iteration part. So the iteration was very less for this federated learning. So the iteration was 100. So just I made it to thousands or that range, and it worked fine for me. So you can try that as well, ma'am. If you have any other queries after trying that, you can reach out to me. We will sort it. Yes, great.
And there is one other query in the chat. Can I read, Sanjay?
Yes.
Any MRI scan image is prone to attack. So how to protect the medical images when relying on AI-based treatment?
Yes. So as I already told, sir, just we should make while training the model itself, we have to give the see. Uh, think of an attacker's perspective, how the attacker will attack the MRI image. Okay, so researcher should be very much proactive than the attacker. So we have to create adversarial images, possible adversarial images for MRI scan, and we have to give it in the training phase of the model itself. And as I told, there are multiple defense mechanisms. See, attacks cannot be stopped. Attackers will attack, but our system should be robust enough to make sure the attacks are being mitigated and our model remains robust and reliable, sir.
Sanjay, there is one other query.
Yes,
Meanwhile, the person who raised the query has thanked you.
yes,
Can I read?
yes, ma'am.
Can you explain LP normal? No, I think it is normalization briefly.
LP, okay, ma'am. So I think ma'am is asking some mathematical concepts, I believe, as LP norms will be coming under linear algebra. Uh, i- is it so, ma'am, or you are asking in AI based explanation? Uh, Ma'am, can I get a confirmation in what concept you are asking and you want some clarification?
Dear participants who raised the query, the person has said it is enough. The person understood it seems, Sanjay.
Okay, ma'am. Yeah.
If there are any further queries, probably you can send the queries to the registered email ID of the FTP, and we'll take back to Sanjay, and we'll get back with the responses back to you. Since we have only 5 minutes for the closing session, uh, I think I can formally thank Sanjay for it. So before thanking Sanjay, we just want to tell a small info to the audience that Sanjay was my project student here, and he graduated from here as a topper of his batch. And it's very happy to see my student grown to greater heights. And when they come back, teach us back, that is the proudest moment, it seems, right?
Yes,
So,
ma'am.
for the first time, while thanking a speaker, I wish to thank with a proverb like this proverb I've taken only specially for Sanjay. The fruit laden tree boasts the lowest. The quote means that the idea that the true knowledge and wisdom leads to humility and not arrogance. It emphasizes the importance of staying grounded and respectful, especially towards those who guided your journey. So I think even after getting graduated from here, whenever he turns back to me, either in a virtual mode or a physical mode, I still I could see the same gratitude in him as a student. But when I see his growth over there while he presents and shows all kinds of demo, I feel literally very proud of him.
Thank you, ma'am.
And
It's all because of the foundation you laid to me. So, yes, I'm extremely grateful that I got a uh, intellectual project guide as you know.
So God bless you, Sanjay. We extend our heartfelt gratitude to you, Mr. Sanjay Krishna, the cloud engineer from Deloitte, for gracing the last session of the Faculty Development Program on Responsible AI, conducted by PSG College of Technology, sponsored by AICT ATAL. And thank you so much for accepting the invitation to handle 2 consecutive sessions, and that too the last 2 sessions of the last day of the FTP. Thank
Yes,
you so
ma'am.
much.
So thank you so much, ma'am, for this opportunity, and I thank all the participants. All the best for your future research work, and I also thank Surya, ma'am, for making this session a huge success. Yeah.
Thank you, Sanjay. Um, Meanwhile, participants, you can stay back